The moon stole something from deep inside our Earth eons ago, and scientists can prove it. Earth and its moon are unique in their solar system. Earth is the only planet with just one moon, and that moon is pretty influential. In fact, without the moon, life on Earth may not have emerged, some research suggests. Let's remember that billions of years ago, the Earth was about the size of the moon. The Earth is growing at the size of a human fingernail every single year. Now, couple that with this bizarre ratio. Unlike any other planet-moon system we've seen, the moon is a little over a quarter the size of our Earth. Scientists naturally are interested in where the moon even came from. There are some scientists that claim that the moon is older than the Earth. Now, many, like the potato-shaped pair of rocks that orbit Mars, the Mars moons Phobos and Deimos, are captured asteroids. Scientists believe that the origin story of the moon, however, is one of fire and fury, a vast spray of debris gouged out from a still warm, barely formed Earth on a massive collision with a Mars-sized planet named Theia around 4.5 billion years ago, and that debris, the theory goes, coalesced to form our satellite, the moon. This is just a theory. And now we have new evidence of that violent birth. Isotopes of the noble gases helium and neon trapped in lunar meteorites recovered from Antarctica match up with those found in the solar wind without ever having been exposed to it. This, together with the signature argon isotope concentration, suggests that those gases were inherited from Earth, wherein the two bodies were one long ago. Finding solar gases for the first time in ballistic materials from the moon that are unrelated to any exposure on the lunar surface was such an exciting result. This is what cosmochemist Patricia Will, formerly of ETH Zurich in Switzerland, now at Washington University in St. Louis, said. Directly studying the composition of the moon is a complicated business. We have not been there since 1972, and collected samples are scarce. Now, why have we not been there all these years? 50 years now is a very significant question that needs answering. But going back to this, the moon, however, does occasionally come to us in the form of meteorites that are thrown in our direction when something large slams into the surface. A bunch of these lunar meteorites, or lunates, have been recovered. There are several hundreds that we know of, found all around the world. The subjects of the study by Will and her colleagues are just 6 fragments recovered from Antarctica. These fragments are all part of the same original meteoroid and consist of a very specific kind of rock, unbrachiated, that is, not a fruitcake of multiple rock types, as many meteorites are, basalt from volcanic plain on the moon. This rock formed when magma oozed upwards from the interior of the moon and cooled quickly, covered by more layers of basalt, and thus protected from the ambient environment, including cosmic rays and solar wind. When the basalt cooled, particles of volcanic glass formed and crystallized and remained there under the lunar surface. And there the rock lay until an impact massive enough to send lunar rocks flying to Earth. Such an impact would have to have been relatively large, gouging deep into the lunar surface to reach rock that had not been exposed for eons. To find their secrets, the research team studied the lunates using a noble gas mass spectrometer at the ETH Zurich Noble Gas Library. This instrument is one of the most powerful in the world, and the only one, the researchers said, that's capable of making their detection. The sub-millimeter glass particles in the basalt the team found retained isotopic signatures of helium and neon, like tiny time capsules. And these signatures were the same as the solar wind, but were detected in much higher abundances than expected. Because the basalt had not been exposed to the solar wind, the gases had to have come from somewhere. The team found the isotope ratios of the neon were very similar to isotope ratios of neon in Earth's mantle plumes, deep upwellings of hot molten that sample reservoirs of deep material deep inside Earth that are unlikely that are likely undisturbed since the planet formed 4.5 billion years ago. This similarity suggests that the gases came from Earth, the researchers concluded. The discovery may prompt renewed interest in the study of noble gases in the meteorites, and a closer look at what else may be locked up in other lunar rocks that was previously undetectable but now within reach, such as hydrogen and halogens. While such gases are not necessary for life, it would be interesting to know how some of those noble gases survived the brutal and violent formation of the moon, said geochemist Henner Bussmann of ETH Zurich. He said such knowledge might help scientists in geochemistry and geophysics to create new models that show more generally how such most volatile elements can survive planet formation in our solar system and beyond. This was published in Science Advances, and it's on Science Alert by Michelle Starr. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.